right, I guess we can go ahead and kick off here. This talk is, it's about a tool called Grimoire, and the title of the talk is Because Your Cloud Logs Shouldn't Be More Mysterious Than Actual Magic. The backup title for this talk was Grimoire, Because You Gotta Catch 'Em All. So, you know, we can kind of A/B test that as we step through the deck here. I'm Andrew. I am the curator for the Wild West Hackin Fest Toolshed. I come to the farm thing as like a lifestyle choice, and like this is kind of the costume. So if you're wondering like what my daily life looks like, it looks a lot more like Wild West Hackin Festy stuff than it looks like hackery, cybery stuff. That is a real 1968 International Harvester that I use to cut my alfalfa. I also do private corporate training. I work as a cloud security auditor. I do architecture and design guidance. And I also do some executive coaching now, which is like a really weird new thing. But it turns out some people just want a technical person to listen to their problems. So if any of those things are interesting to you, because I am also a bad capitalist, you can hit me up, because it turns out when you give money away, you just need more of it. And that's kind of a problem that I think I struggle with. So we can't really talk about this tool without talking about detection engineering fundamentals. And do I have anybody in the room that's currently doing detection engineering today? This is kind of like an emergent new term. Like we didn't really see like the job role detection engineer come onto the scene until quite recently. I think this is more prevalent in cloud, but even in like the on-prem sort of shops now, we're starting to see some detection engineering roles pop up. It is the process of crafting, validating, and operating your detections. So I work in cloud. If you know me or you've taken my class, I only do the AWS cloud. I don't do any other clouds. I am absolutely a specialist, and I teach the cloud security foundations for anti-siphon. So I come at this from the perspective of like, what are the indicators of compromise for cloud? So you could have all kinds of different IOCs in cloud provider environments. They could be everything from like a supply chain sort of an issue to a Docker image name to like very specific indicators that are agnostic of cloud environments. They kind of fall into two categories, right? We have some IOCs that are really easy to detect, and then you have IOCs on the attacker side that are hard to maintain good detections for and easy to change for attackers. So like a great example is attackers are really good at changing their source IP or potentially jumping account IDs if they have access to multiple accounts. So that's a great way to say that maintaining the life cycle of a good detection over time can be really, really challenging. And so everybody has kind of seen this pyramid of pain for the things that we use to build good detections. And in the last like decade or so, we've made a shift as an industry of thinking of detections as like a discrete map to one of these indicators of compromise to more a set of behaviors that we see unfold in the environment. Because if we just detect on one of these, not only is it easy for the attacker to change, but we're also going to have a very high rate of false positives and lose confidence in the detection system that we're using. So we have to think like an attacker in order to be a detection engineer. So you come at it from the perspective of like, what does an attacker actually want to do when they breach a cloud environment, right? And the answer is not always cryptocurrency mining. There's a number of much better, juicier targets than just like the drive-by style malware that spins up cryptocurrency miners. So we can take all of that, like what are sort of our own personal threat models, behavior models, public cloud incidents from websites like breaches.cloud, and we can turn that into kind of like an informed strategy for the way that we think about building detections. MITRE actually just barely got on the cloud attack train as well. They released the MITRE attack matrix specifically for cloud, which actually for the first time I can say the behaviors in this matrix are actually quite relevant to the way that the majority of vendors in the market today are building out-of-box detections for all three large clouds. So if you break it down, it doesn't really look that different from like a phases of attack. It does look different from the sets of technologies that are involved. So, you know, just the control plane itself is one piece of the cloud, but then the abstract infrastructure that runs on top of it also becomes another set of logs that we have to bring in and consider in context when we're building detections for the AWS cloud in this case. So we have everything from, how did we breach the cloud environment to like, I got into a Docker sidecar container in a Kubernetes cluster and I executed some very specific container injection or container escape in order to pivot to the next step. Microsoft also just got on board this because everybody likes releasing matrices, and they released their own threat research matrix as well. That's a mapping of the same kind of stuff to the Azure cloud. A lot of vendors on the market and open source practitioners are also creating catalogs of attacks and attack tactics. So me and my team, we maintain this thing called Cloud Security Atlas at Datadog. It's a mapping of some of the most prominent types of attacks that we see in customer environments, and we write these down in plain English that anybody can understand, along with a set of indicators of compromise to detect them. Here is another example from Wiz, who's another vendor in the cloud security space, from their database of techniques as well, which is to say that there are just a lot of sources that you can draw on to kind of see what you should care about. Just, I did mention breaches.cloud already. There's lots of great blogs out there. We also see these things come up in industry reports like Mandiant, M-Trends, Verizon VDBIR, CrowdStrike's Threat Hunting Report, the Sysdig Cloud Native Threat Report, Orca's Honeypotting in the Cloud, Google's Threat Analysis Group Bulletins, and blogs from individuals. So this is to say there's just a lot of material that you have to like slog through in order to think about building your detection strategy. But like if we're detection engineers, we need to think about all this stuff in context, and we need to think about it in a way that is relevant to our environment. Because like a lot of times, if we just take the out-of-box strategies or we take discrete attack paths from something like the MITRE attack matrix, it doesn't really work for our specific implementation very well. Because like everybody's kind of a snowflake and they build their application in its own way. It has its own threat model. But we know the behaviors that we want to look for. So like where do you even get started with something like this if you have all that surface area and you have all that information to start building detections? So first you want to start by cataloging and classifying your cloud environment, centralizing and understanding what logs you have access to and what enrichments you might need in order to correlate them. And if you don't know what that means, enrichment is just a fancy way of saying we sprinkle breadcrumbs in the logs to know like potentially what instance they came from or what account they came from to make the process of correlation easier. And then maintain healthy skepticism towards your detection rules. Like basically, I assume that they don't work most of the time until I have proved that they do. And the opposite mindset can actually be quite dangerous if you think that you have a detection in place that is working, but you don't have the ability to exercise that detection. Because if we think about the maximum risk scenarios in all of our application stacks, those are things that should almost never happen. And if they do, lots of alarms should go off. But if they don't fire, and we don't exercise them, we have no way to actually prove that they work. So when you're cataloging and classifying your cloud environments as well, you need to take into account not just production. And I can't tell you how many times somebody gets owned and there's like a pivot to production through development or test account. This was like a big theme in breaches in 2024. It's still a big theme this year. I suspect it's still going to be a big theme next year. Centralizing your logs is a big part of it as a predecessor task as well if you don't have one place. And the last speaker mentioned Vector as a means of ingesting, transforming, and potentially multiplexing logs. That's a great way to centralize them as well. So then you need to understand what it is you have access to, right? So we have control plane audit logs, we have data plane audit logs, which is when people access data in your infrastructure. We have network level logs, because in the cloud, you can't just PCAP all the things. In fact, most cloud service providers don't actually support generating full packet captures. You have to start with NetFlow data equivalent, and then if you want that packet capture level visibility, you have to do that at the host or network interface level. DNS query logs and load balancer logs, WAF logs. You're just like literally drowning in logs in these environments. So the enrichments are where it actually gets quite interesting, is like doing things like resolving the account IDs, correlating tag sets, IP addresses, email addresses, and now we're starting to see a trend in the industry as well, where the most mature shops are also bringing in things like application context by default to these logs, so session IDs, usernames, etc. So we can begin to build stronger correlation from single data event. So here's an example of just like an enriched log that includes all the useful stuff like account ID, user information, source IP. Here's another way that we might enrich that same structure. So we have AWS account at the top level, we have user as another node, and then all the things that we need to know about that person. We might have to get that from another database. Like I said, the biggest challenge in this is not like getting the data, writing the rules. It's actively monitoring to ensure that you have confidence in your detections over time and that you're not just generating a bunch of false positives. And when detection engineers write rules, in order for them to drive down that false positive rate, they need very short feedback loops to exercise the detection and make sure it's actually only alerting on the things that we want it to alert on and not on anything else. So when you do go to write custom detection rules, it's different in every platform right now. So like based on the SIEM that you use, every vendor has a specific syntax. There are transpilers and crosspilers and all these different tool chains to write detection rules. They're not great. Like Sigma hasn't really solved the problem. People are onboarding to OCSF, which is the Open Cybersecurity Schema Framework, which is probably the best standard effort I've ever seen in my 20 years of working in this industry. But it's still not perfect because everybody has like kind of a flavor of it that they've implemented on top of their thing. So if we just take our goals, like we want to detect malicious activity, we want to detect things like identity non-compliance, so not just threats, but also misconfigurations. We want to flag potentially interesting events that merit more investigation. And we want to treat those differently in next step scenarios. So like malicious activity, we want to triage and respond. Identifying non-compliance, we want to actually get that stuff out of the environment. And flagging potentially interesting events, that's the stuff today that people are outsourcing to large language models. They're saying like, hey, LLM, I'm not confident enough in the interestingness of this to pass this on to a person, so instead I'm going to pass that to a fine-tuned set of context in a large language model to get more information. And then when you're this % more confident, go ahead and pass that on to a person because we've decided that that has met our minimum score to actually bother an employee. Alert handling playbooks are a big part of this when you're writing detections. Like how do you actually go from log to detection to like what a person should actually do when they triage and investigate that. And building an alert severity framework is equally important as well because the criticality of an event is also going to be different for every single person in every single case and every single business related to like potentially things like the data set or the context of the account the workload is running in. So coming back to the entire point of the tool, the point of the tools I'm going to show you, that was a very long way to say, is to write better custom detection rules and have confidence in the fact that those are working 100% of the time. So one of the ways to do it, one of the ways that you can write detection rules and go through these fast feedback loops is to use detection as code. And we came up with the term detection engineer. Engineers write code. There's no reason why in your SIEM, in your place of work today, you can't write detection as code. And this is an example on screen here of actually writing a rule in detection as code for Datadog in Terraform. So what we can do is we can actually do things like tag these with the MITRE ATT&CK IDs. We can create the query, and then we can push that into the SIEM platform, and we can see if it fires in specific scenarios. As code is also like kind of a buzzword in industry, so I just want to define what I mean when I say this, because I don't think a lot of people understand all the time what I mean. It's not just the act of writing and describing the rule as code. It is the act of going through all of the things that would normally be in the software development lifecycle for our detection rules, which means that we have things like a mature development environment. We're pushing those through a continuous integration, continuous delivery pipeline, and we're running things like unit tests to have confidence that those actually fire 100% of the time. So this is the question that you should be laying awake at night and asking about all of your detections. Are they actually working? Because I cannot tell you how many times I have seen in real environments, we got breached, we had a detection for that, but sometime in the last 2 years since we wrote that detection rule, that list of, that dictionary became a list of dictionaries. And instead of actually finding the field that we needed to alert on, we alerted on nothing because we effectively had no data. So what we want to do is we want to be able to reproduce the attack, observe the generated data, and develop and improve the detection. Sounds straightforward enough, right? So we want to go through all these phases continuously. About 3 years ago, we released a tool called Stratus Red Team, which was an adversary emulation framework for cloud, sort of similar to what Atomic Red Team does, except Stratus Red Team is software. It spins up, it actually goes through all the same tactics that a threat actor would and produces all the artifacts inside of a clean room environment to execute. I think it's 36 different attack tactics for AWS now. We also have them for Kubernetes, GCP, and Azure. So that was great because we could make the attacks, we could observe the data, and then we could write the detections. It solved the challenge of hard to set up prerequisite infrastructure. You were able to go through and exercise everything from contrived attacks, like disabling CloudTrail, all the way up through like all of the different complex attacks that exist in that MITRE ATT&CK framework. This is just an example of how many things you would have to click on in order to actually do it if you were doing it by hand. You can see it's quite long just to go through the CloudTrail enable, disable part of it. This is one line in Stratus Red Team. So it's a catalog of attack techniques described in code, in software that you can use to exercise your detection mechanisms. Those are all publicly available on stratusredteam.cloud. So that lots and lots of them out there. At the end of the day, these are all just like Terraform files, so it's really easy to understand what it is they do. It also has an API that you can bind to in other tools in order to drive Stratus. So if you want to create another Golang tool that uses this as part of it, and a couple of vendors have actually taken this open source and put paid wrappers around it, you can do that to create attacks as code. Now, when we do this, regardless of how complex or simple the attack is, it goes through 3 phases to sort of exercise the detection. It has to go from cold, where you don't have anything spun up, to a warm state, where it puts up the prerequisite infrastructure, and then the attack detonates. And that's the part that you want to capture in order to test your detection or go to the platform and see if the behavior that you exercised was detected. This is what it looks like on the command line. We don't have time to do like a comprehensive demo of it, but it goes through all 3 of these phases in the detection engineering lifecycle. Now, this allows you to go from attacks to logs relatively easily, but you still have to like go to the log store and get the logs and pull them down and hand them to a detection engineer in order to write an accurate detection. And that's kind of a problem, right? Because we talked about one of the tenets of good detection engineering being fast feedback loops. And so we decided to create a companion tool for this as well, which is called Grimoire. Grimoire it uses the Stratus Red Team API to detonate attacks in AWS. It uses a special feature where you can pass in a UUID in addition to the user agent so that all the logs that are generated in the back end have that unique identifier on them, and then it uses a special API in AWS called the Lookup Event API to pull back all of those logs and just dump them out to JSON. So like for the first time, what we have is this very fast feedback tool to detonate attacks, and then the user of the tool receives just blobs of JSON that they can use to go and write good detections. So this is what Grimoire looks like when you run it on the command line for a Stratus Red Team attack. It's just saying, like, Grimoire, go ahead and run this attack technique, and then give me the logs that you generated in this place, and then I can take those and I can push them into any other process I want to push them into. This is also a place where a large language model can be really helpful. Has anybody heard the term context engineering? It's a new term, like kind of in the LLM space that people are kicking around. If you want to take a language model and you want to make it more deterministic, that is based on the amount of good quality context you're feeding into it. And if you have this rich library of events that's mapped in a friendly way to MITRE attack tactics, you can start to do things like have an LLM propose initial detection rules that covers that type of attack. This is an example of the interactive shell, because like one of the limits that we didn't want to have in Grimoire was that it was limited to the 36 attack tactics in Stratus Red Team. So what you can do if we don't support it is you can spin it up as a REPL, and then you can run as complex an attack path as you want, pivoting through as many services as you want to pivot through, and it will still do the same thing and go and grab that really rich JSON, put it on disk in a format that's easy for you to work with and analyze. So Stratus Red Team and Grimoire go together really, really well. I don't know if anybody is old enough to remember this movie. I have a habit of putting old movie images in my slide decks, and there's always like a Gen Z person in the front that's like, I don't know what movie that is. But this is from Titanic. So you get the, we call them detonation logs. And as far as I know, this is the only tool on the market that actually has this concept baked into the tool itself, where not only do you have the ability to go and get this stuff, but you also have the ability to create suppression lists in your current SIEM so that your adversary emulation doesn't false positive trigger your current detection rules. So to wrap up here, these two tools help you stay aware of what attackers are up to in AWS. They help you control and know your logs. And they also help you continuously challenge and test your detections, which is one of the hardest things, I think, in cloud, with just the notion that, you know, inside of the SLA and the agreement, the providers can just change the log format out from underneath you. So having a way to write these and continuously test them is really essential to any detection strategy. And with that, that's me. That's where to get a hold of me if you want to hire me to do stuff. Thanks for being here at the final talk in the tool shed today. Any question? A question in the back?
Question about you were saying that a lot of people are using LLMs for their to ingest the log. How have you seen that worked out? Has it been a pretty bad situation? Like, there's a lot of gaps that's happened because of the LLMs, or is it mediocre? Or it just depends on how they're building?
Is your before I repeat the question, I just want to understand: is your question about getting logs from large language model providers, or is your question about using LLMs to write the detection rules?
Using LLMs to write the detection rules, you said they wouldn't be large to human until like it passed the LLM stage.
Yeah, the results widely vary based on the model, based on the data sources, how good that model is. I personally have had good success using Claude Code to write detection rules, particularly for Datadog. Amazon Q Developer also has a lot of built-in context for cloud-specific threats, though I haven't really spent a ton of time writing detection rules with either yet. It's just kind of a new concept.
For the Stratus Red Team tool, are you assuming that an end user would be using a built-in policy in AWS? Do you provide a policy for all of the required actions that you're going to need?
So the question was, for Stratus Red Team, what sort of identity and access management policy do you have to delegate to Stratus? Because Stratus is detonating all those attack tactics, our recommendation is that you run it in an isolated environment that's a clean room in your organization. So if you're an organization's customer, you're running that inside of a dedicated account that you can also then use in your suppression list. because it more or less has to have full-blown administrator access in order to do what it needs to do.
You're pretty like start on
Yeah,
that.
yeah. So put it in a dedicated account that you're going to use just to exercise the SIEM. Like, don't run it alongside production workflows. Of course, if you only wanted to test a couple attack tactics, you could do a scope down policy for that was just related to those, and you could use things like condition keys for tagging. But at that point, you're just working a lot harder than you need to.
Follow-up question as well. One of your slides, you had showed like I was assuming it was an attack, and then like what actions in AWS are going to be that one.
This one?
Two more forward.
This one?
That one.
Okay.
Are those for? Do you have that for all 36 attacks?
We do. So it was actually, so the question was, do we have the list of IAM verbs that we expect to be part of the events as part of the attack tactic maps? It was actually the creation of Grimoire that allows us to generate this in the documentation. So what we have done as well is we've created a library of sample JSON for everything that's also supported by Stratus, and that's actually part of the documentation now. We could not have got this without creating the companion tool, at least not easily, in a maintainable way. Any other questions? All right, well, with that, I'll leave you to it. Hope to see you at the closing ceremony, and please don't forget to submit your tool shed or regular talk submissions for Wild West Hackin Fest Mile High in Denver in February. It is the easiest way to get a free ticket, because we still give you a free ticket for your 15-minute talk. All right, thanks.